The latest news about 3I Atlas is being deliberately withheld. Countries including NASA have collectively chosen to remain silent. In today's video, we'll break it all down for you. As the first interstellar object to enter our solar system in 6 years, since its discovery by NASA's Atlas telescope in early July 2025, scientists worldwide have been thrilled. In just 2 months, related research papers surged from 4 to nearly 70. Now, there are only days left until its closest approach to the Sun on October 30th. This comet travels at 58 kilometers per second. It could be over 10 billion years old. How many unknown secrets does it hold? The name 3I Atlas has 2 meanings. First, it's the third interstellar object discovered by humans. Second, it honors the Atlas telescope that discovered it. Previous interstellar visitors we've seen were Oumuamua in 2017 and Borisov in 2019. But this one is different. It's moving faster and much older, estimated to be 3 to 11 billion years old, roughly the same age as the early solar system. Most importantly, it's currently heading toward the Sun. With each step closer, it reveals more details we've never seen before. On July 21st, 2025, when the comet was 446 million kilometers from Earth, Hubble captured a crucial photo, showing stars in the background streaked, visually demonstrating its incredible speed. Even more importantly, its icy nucleus and surrounding dust appear teardrop-shaped. Based on this image, scientists calculated its true size, with a diameter between 440 meters and 5.6 kilometers. Much smaller than initial estimates. The brightness we saw earlier was from the dust cloud around the nucleus, not the nucleus itself. Now that the dust has cleared, we can see its true form. Soon after, the Webb telescope joined the observations. On August 6th, led by astrochemist Dr. Cora, using Webb's near-infrared spectrometer to analyze its composition, found something even more interesting. This comet's coma has an exceptionally complex structure. More unusually, while most comets' comas point away from the Sun, 3I Atlas has significant dust spreading toward the Sun. There was another surprise. From the Transiting Exoplanet Survey satellite, TESS. Previously, it was thought the earliest observation of 3I Atlas was on June 14th. But when the TESS team reviewed their data, they found they had captured the comet as early as May 7th to June 2nd. By comparing brightness data, scientists verified previous measurements. This comet is far more active than we imagined. Beyond taking photos, ground telescopes also measured its spectrum. Assistant Professor Yangbin from Portales University detected CN band emission features in the spectrum, meaning the comet is releasing cyanide molecules. Typically, comets show this behavior when they're about 3 astronomical units from the Sun. And 3I Atlas is exactly at that distance now. More importantly, by measuring the ratio of diatomic carbon to cyanide, scientists classify 3I Atlas as a carbon chain-depleted comet. Simply put, in its coma and tail, long-chain carbon molecules like C2 and C3 are particularly scarce. This characteristic reflects the primordial environment where the comet formed. Recently, there's been another breakthrough. Scientists began studying the comet's light polarization properties. On September 5th, the Zurich Gray team published a paper, first revealing its polarization observation data. They discovered 3I Atlas has a unique feature, an unusually deep and narrow negative polarization branch. Simply put, its light scattering pattern is different from any comet or asteroid we've seen in our solar system. It might even belong to a type of small celestial body we completely don't understand. What everyone's most anticipating now is October 30th. When the comet reaches perihelion, it will be about 1.4 astronomical units from the Sun. Unfortunately, because it's so close to the Sun, we won't be able to see it clearly for now. We'll have to wait until early December when it reappears to continue observations. But there's no need to worry. All astronomical facilities worldwide will be watching it. When it emerges from behind the Sun, plenty of new data will surely surface. There's one ultimate question. How long has this comet been traveling through space to reach our solar system? Can we trace its origin? These answers await further observations. But one thing is certain. The truth is getting closer to humanity.